Welcome students. Now today we are going to start need of measurement of a class 11th physics topic from the chapter unit and measurement. So let's begin with this topic first. So students, let us explore some questions. Why does rainbow have a specific colors in the specific patterns? Why do stars twinkle? What is meteoroid and why do day and night occur in a cyclic way? All these questions lead one thing, that is a curiosity, and a curiosity leads science. So, what is science if I'm just moving ahead? So, science is a systematic knowledge of a physical or a material world gained through observation and experimentation. Now, observation, and that means if we observe something, look something, and experimentation if we do some practically things. So observation need not to be correct always. Like this is a railway track, as you can see. This is a not actually parallel, but what we know, this is a parallel. So can't trust on any observation. We need experimentation, and by the help of experimentation, we are prescribing that okay, these things are actually correct. So the purpose of experiment to establish the laws, hence measurement of different physical quantities is extremely important. So this is actually develop the need of measurement. Suppose we just want to calculate something new. For example, if I'm just taking a particular object, which is like this, tension. If I just tell you that, okay, just tell me the volume of this particular device. So what you will do? In a regular shape or a size material, I think you heard about the Archimedes principle. So what you will take? A beaker and just put this particular stone and how much water actually emerged out. You just calculate the volume of that water. From From that, you can easily calculate the volume of this box. So what we did? We did a particular practical, and by the help of a practical, we calculate some data. So this is a data by which we need some actually terms. So what are those physical quantities called in the physics? So these are few quantities which we are called as a physical quantity, which we can measure. So the quantity which can be measured is called as physical quantity. For example, length, mass, velocity, temperature. Non-physical quantity is a physical quantity that cannot be measured. For example, love, hated, like. So these are the quantities which can't be measured. Like how much we are just loving to a person, we can't actually judge. Like if I just giving you the flower and you like mostly the flowers, so you don't actually judge. You can't judge that. Okay, I like this much. There will be not number prescription over there. So if you just not be representing any term by the help of a number, so that means you're not able to measure that particular thing or quantity. So that kind of a thing is called as a non-physical quantity, which we can't actually measure. We feel that okay, we love a lot, we like a lot, or we hate it a lot, but a lot is not a particular measurement. Understood? So students, this is a kind of a thing. What is a fundamental quantity? A physical quantity which does not depends any other physical quantities. Like we have taken different kind of a physical quantities previously. So if they quantities are individually, they have their own properties, own nature. So we are saying that is a fundamental quantity, means they have own property, their own. They do not depend any other particular quantities. Like if I'm just saying that okay, rose is a better than hibiscus. So we are just relating, comparing, but rose have their own special properties. It do not depends on the hibiscus. Clear? So I'm just taking one example for understanding over there. So fundamental quantities are those quantities which do not depend any other quantities. Like earlier, which we taken the example of a like rose and hibiscus. So in both the cases, rose and hibiscus, if the hibiscus is a continuously growing, that not impacting on the rose. And similarly, rose is a continuously growing, and they give the beautiful red color, so that not impacting on the hibiscus plant. Understood? So they are both different things. So these are the things which we are taking as a fundamental terms. Now, fundamental quantities. We have 7 fundamental quantities. So all the quantities are emerging over there. We are just taking the example on the other side. So the first thing which we have is that length, mass, time, temperature, amount of a substance, electric current, luminous intensity. These are the things. Length L, mass M, time we are saying as a in the dimension capital M, capital T, temperature theta or K, amount of substance mole, okay, MOL, mole, electric current ampere, and for a luminous intensity candela. So these are the small representative term. The thing which we have, remember, we have 7 physical fundamental quantities, and they fundamental quantity have their particular unit also. So we have 7 fundamental units, and their symbols. So we have 7 fundamental quantities symbols also. So is a measure of intensity or a brightness of a light. Supplementary quantities, we have 2 more particular quantities which we are saying as supplementary quantities. They are measuring angle actually. So plane angle and solid angle, they are both special. Actually we can measure the angle by the help of arc and the radius. So we have a different kind of a quantities, other supplementary quantities which we are taking. Angle inscribed by the surface at any particular point is known as solid angle, like this. So there are 7 fundamental quantities as we know, 2 supplementary quantities. Now, if I'm just talking about the derived quantities, so what is the derived quantities are? Physical quantities which is derived from more than one fundamental quantities is called as a derived physical quantities. For example, area, density, force, acceleration, work. So if I'm just taking the example of some derived quantities that are velocity, which is in meter per second. Velocity is equals to displacement by time. That we know. Acceleration is equals to velocity by time. Work, force into displacement. So now here I'm just wanted to explain some more thing. Like velocity is derived quantities. Why we are saying? Because here we need to describe this velocity again in the terms of meter and second. And what is a meter and second? This is a fundamental units. As you can see over there, displacement is a length, part of a length. Time is again the fundamental quantities. So these the quantities which is depending on the fundamental quantities. Similarly with the acceleration, like a formula for acceleration is the velocity with time. So acceleration we can write over there like this, velocity by time. So velocity we can write like displacement by time into 1 by t. Displacement is nothing but actually length. So we can write as a L by t square. And again, this is a fundamental part. This is again the fundamental part. So that's why we are putting the unit meter and second square. This is a part of fundamental quantity, students. And second is also part of fundamental quantities. So basically, overall, what we can say that our derived quantities are those quantities which is depending on the fundamental quantities, and the derived unit is what? Derived unit is a kind of unit which is depending on the fundamental unit. And what is the mean of fundamental? Fundamental means basic, and they do not depend on any other quantities. These type of quantities are called as a fundamental quantities.